Alright, Jen, strap in, because we are talking about something today that is it's big. NVIDIA just dropped something significant in the robotics world.
Oh, I saw that. NVIDIA GR00T N1, right? The name itself sounds like something out of a sci-fi movie, like Groot from Guardians. So what exactly is this GR00T N1?
Okay, so GR00T N1, and yes, it's pronounced like that tree, is NVIDIA's first open foundation model, but specifically for humanoid robots. Think of it as like the core intelligence, the brain, for these really capable machines.
A brain for humanoid robots. That's a bit unnerving and exciting all at once. So this isn't just for one specific type of robot then? The foundation model? Meaning it's adaptable? You mentioned open too?
Exactly. That's the essential part. Because it's a foundation model, it can be adapted for a wide variety of tasks across different industries. NVIDIA's angle here is really addressing the notable global labor shortages we're seeing, which are apparently over 50 million positions. They envision these versatile humanoids helping to bridge those gaps.
Okay, addressing labor shortages makes sense, especially in certain sectors, but open foundation model. Can we break down what that truly means in the context of robots? How does being open and a foundation model make it so versatile? Like, what does foundation imply here?
Great question. Being a foundation model means it's pre-trained on a massive dataset. This gives it some foundational understanding of the world and basic skills. Then, being open means developers can build on top of it, customizing it for specific tasks and environments. It's kind of like a highly educated new employee who can quickly learn the specifics of a new job or industry.
Okay, that analogy helps make it a bit clearer. So definitely less starting from scratch for each new robot iteration or task. Now, I also read something about this model having a dual system cognitive architecture. That sounds complex, almost like how a human brain is sometimes described.
That's where it starts getting really interesting. It is designed to mimic how humans think in a simplified way. They've got what they call System 1 foot and System 2. System 1 is all about speed. It processes sensory input in real time for rapid, almost reflexive actions, like quickly reaching out to stabilize if you stumble.
Okay, the quick, unconscious reactions. What about System 2? That sounds like the more deliberate part.
Precisely. System 2 is the slow thinking part. This is where the complex decision-making happens. Planning a sequence of actions, understanding nuanced instructions, that kind of thing. It's where the reasoning comes in. By having both, the robot isn't just reactive. It can also thoughtfully plan and execute intricate tasks. It's a pretty elegant design, really.
So it can react fast to avoid bumping into something, while simultaneously figuring out the most delicate way to pick up a fragile object? That seems like a crucial combination for real-world robots operating in dynamic environments.
Exactly. It bridges that gap between just reacting to immediate stimuli and actually understanding context and planning ahead. And to train these models effectively, NVIDIA is doing some equally compelling things, like heavily relying on synthetic data. They've got something called the Isaac GR00T blueprint that can generate over 780,000 training examples in under 12 hours. That's a lot.
Wow, that's a significant amount of data, and generated remarkably quickly. Synthetic data, That means it's computer-generated simulations, right? Not from real-world recordings of robots in physical spaces?
Yep, precisely. Instead of having to set up physical environments and record robots doing things over and over again, which is time-consuming and potentially risky, they can simulate countless scenarios virtually. This allows them to train the models on a huge variety of situations and movements much faster and safer than in the real world. They can test edge cases they might not encounter in simple lab setups.
And I noticed they're collaborating on the core physics engine for this with some interesting partners. Google DeepMind and, wait for it, Disney? That's a mix I wasn't expecting to find in a robotics project.
Right? You hear Disney and you probably think theme parks and animated movies. But they actually do extensive advanced research, especially in simulation, animation physics, and character behavior. Partnering with them and Google DeepMind, recognized leaders in AI research, on the Newton physics engine means they're leveraging top-tier expertise in making these simulations incredibly realistic. And accurate physics are essential if you want a robot trained predominantly in simulation to perform well in the messy, unpredictable real world.
That connection makes a lot of sense when you think about it. Realistic simulation leads to better real-world performance because the training is more relevant. And speaking of performance, I saw some benchmark data comparing GR00T N1 to other models. How does it actually stack up against existing approaches?
Okay, this is where, as a tech enthusiast, my interest peaks. In simulation benchmarks across different manipulation tasks on a tabletop, GR00T N1 is outperforming other state-of-the-art models like BC Transformer and diffusion policy quite significantly. And these aren't minor gains.
Give me some numbers, Mark. How much better are we talking? Is it a small increment or something more substantial?
All right, here are some specifics. In the GR1 tabletop manipulation tasks, for example, GR00T N1 had success rates up to 66.5%. Compare that to diffusion policy, which was around 32.7% in the same tests.
Okay, that's more than double the success rate in that specific type of task. That is certainly not a small difference. That's a considerable improvement.
No, not at all. And similar improvements were observed in other benchmark areas like RoboCasa and DEX-MG, which involve different kinds of object manipulation. It really suggests that this combination of the foundation model approach, the dual system architecture, and the synthetic data training methodology is producing a much more capable and reliable robot brain.
So we're seeing these capabilities demonstrated impressively in simulation environments. Have they actually tested this in the real world yet, with physical robots?
Yes, they have. They've been testing with the GR1 humanoid robot, demonstrating advanced manipulation skills in real-world tabletop environments. They've shown it doing things like reorienting objects on a surface, using tools correctly, and even performing simple assembly tasks. They're reporting notably improved success rates in these real-world tests compared to legacy systems after integrating the GR00TN training pipelines.
Okay, so it's translating from theory and simulation to actual physical robot performance. That's a necessary and very important step. But putting this technology into the real world, especially workplaces, certainly brings up some significant ethical and societal questions, right? It's not just about the cool tech.
Absolutely. While the stated goal is to address labor shortages, particularly in roles that are physically demanding, monotonous, or unappealing for humans, there's an understandable concern about job displacement, especially for roles that require less specialized skills. Industry analysts and researchers are definitely watching this aspect closely.
And how is NVIDIA addressing those concerns? Are they simply saying, robots are coming, prepare for the automated future?
No, they seem cognizant of the implications. They're emphasizing that the primary focus is on automating dangerous or dull tasks, jobs that inherently carry safety risks, or are highly monotonous and repetitive. The hope is that this integration frees up human workers to transition into roles that require more uniquely human skills, such as creativity, complex problem-solving, critical thinking, and interpersonal interaction.
That perspective is definitely crucial. It frames the conversation not just around replacing jobs, but potentially augmenting the workforce and changing the nature of work itself. It's not just about the tech. It's about its broader impact on society and the future of work. So what's next for GR00T N1 from NVIDIA's perspective?
NVIDIA seems to have fairly ambitious plans. They're discussing expanding the GR00T family with significantly larger models, potentially scaling up to 100 billion parameters, which would give them even greater capability. And they're actively developing specialized variants of the model tailored for specific sectors, like manufacturing, healthcare, and logistics.
Targeted robots for specific industries. That makes a lot of practical sense for accelerating adoption. You wouldn't necessarily need a generalist robot for every task.
Completely. And the fact that they're already collaborating with major engineering companies like Bosch and Siemens strongly signals that they're not just doing research, they're aiming for near-term commercial deployment. We could realistically start seeing GR00T-powered robots integrated into warehouses, factories, hospital settings, or even retail spaces relatively soon.
That is an incredibly exciting and perhaps a little bit intimidating prospect to consider. thinking about these increasingly versatile humanoids working alongside us, it does seem clear that GR00T N1 represents a pretty significant step forward for the capabilities of humanoid robotics. It's moving beyond research labs into potential real-world applications.
It really does feel like a pivotal moment in bringing truly capable humanoid robots into reality for broader use. It's going to be fascinating to observe how this technology unfolds and the kind of impact it ultimately has on various industries and, honestly, on our society and how we think about work.
Indeed. We'll definitely be keeping a close eye on GR00T N1 and the evolving future of humanoid robotics. Thanks for breaking it all down so clearly, Mark.
My pleasure, Jen. Always a pleasure to dive into the future of tech and its implications with you.